We will look at the 10 steps of glycolysis in greater detail, but in this lesson, let's just get an overview of the steps and see the overall benefit of the pathway. Phase 1 of glycolysis is referred to as the preparation or energy investment phase. In this part of the pathway, we spend some energy in order to recover it in later steps. An overview of this phase is shown in the figure on the right. Glucose is first phosphorylated to glucose 6-phosphate at a cost of 1 ATP molecule. Glucose 6-phosphate is then isomerized to fructose 6-phosphate in preparation for the next step, which involves another phosphorylation and another ATP cost. The product of this third step is fructose 1,6-bisphosphate. In the next step of phase 1, fructose bisphosphate is cleaved into two molecules, glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, both 3-carbon compounds. The final step in phase 1 is the isomerization of DHAP so that we end phase 1 with two molecules of glyceraldehyde 3-phosphate. We began phase 1 of glycolysis with one molecule of glucose. We begin phase 2 with two molecules of glyceraldehyde 3-phosphate, so we get double the products for each step in this phase. First, Gly3P is oxidized and phosphorylated to give 1,3-bisphosphoglycerate. The subsequent transfer of a phosphate from this molecule generates our first energy product, ATP, with concomitant formation of 3-phosphoglycerate. Note that by the end of this step, we have recovered our initial investment of ATP. 3-phosphoglycerate is next isomerized to 2-phosphoglycerate to prepare for the next step in the pathway, which is water removal to form phosphoenolpyruvate. Our final reaction in the pathway transfers a phosphate from PEP to ADP, giving our final product pyruvate and generating two more ATP molecules. By the end of the pathway, there is a net gain of 2 ATP molecules. With this brief overview, hopefully you can see that the main benefit of the pathway is the direct generation of energy in the form of ATP.